Assalamualaikum warahmatullahi wabarakatuh and good morning. Today we're going to continue on with travel graphs and we're going to look at speed time graph. So by the end of the lesson, the learning objectives are to be able to interpret a speed time graph. So yesterday you learned to interpret a distance time graph. So today you learn to interpret a speed time graph. You'll calculate the distance traveled by an object by calculating the area under the speed time graph. You'll also calculate the acceleration of an object by calculating the gradient and translate speed time graph into distance time graph or acceleration time graphs. So steps to success, the things that you are going to cover today. You're going to use the graph to find the speed of an object at one particular time. So for example, find the speed of an object at t equals to 10 seconds. And then you'll draw portions of a speed time graph. This could also mean 3 different portions for one whole speed time graph. You'll study the speed time graphs closely, portions by portion. This will enable you to translate graphs by finding the missing variables first and also drawing the graphs. Okay, so let's look at some basic speed time graphs. When speed time graphs are flat, they are moving at constant speed. They are not stopping, they're just simply moving at constant speed. If a speed time graph has an increasing slope or an upward slope, they are moving at increasing speed, or in other words, they are accelerating. There is an acceleration, so the speed keeps on increasing, accelerating. Meanwhile, if it is a downward slope, they are moving at decreasing speed. They are decelerating, they are slowing down. So, in a speed time graph, the gradient of a speed time graph refers to an acceleration, the acceleration of the object. Meanwhile, the area under the graph equals to the distance traveled by the object. So let's look at here, for example, if you want to find the acceleration from point O to point A, you will have to find the gradient of this line. Okay? And then for the area, for example, you want to find how far has the object traveled from point A to point B, you will find the distance under the graph. Okay, so if you find the distance under the graph for this part of the graph only, then you're only finding from point A to point B. If you want the whole distance from point O to point B, you will have to find the area for the whole graph, which means you have to find the area for this graph first and for this part of the graph first, then you add with the area for this part of the graph to find the total area. Okay, next is when you have a curve in a speed time graph. So like I said, the gradient refers to the acceleration. So here you can see an increasing gradient, which means an increasing acceleration. So you are speeding up more and more every time. And then for a decreasing gradient, it will be a decreasing acceleration. The difference with decreasing acceleration and deceleration, for deceleration you will have a downward slope, which means you're slowing down, you're braking. But if you have a decreasing acceleration, it means that you're still speeding up but at a different rate. So you are speeding up faster here and you are speeding up at a slower rate here. For example, you're speeding up every 20 meter per second here, but here you're just speeding up every 5 meter per second. Okay? Next, to translate a distance time graph into the speed time graph. So first of all, here I show you the working. So we work with portions. So for example, here, the first part of the graph is an upward slope. So I will find the speed from t equals to 0, t equals to 8 first, which is the gradient. The speed in a distance time graph refers to the gradient. And then I will find the next portion of the graph, which is this flat line. This is the working. So I have 0 meter per second because the distance is not changing. Then you will translate this into a speed time graph. So you will simply, since it's a straight slope, you will simply have a flat line because it is moving at a constant speed. And when you have a zero speed, 0 meter per second, it will be a flat line at the bottom. So note here, do not draw the line this way, because a slope in a speed time graph means that it is slowing down. Meanwhile, it refers here, tells you that it's 0 meter per second. So it's stopping, not slowing down. Okay? Okay, let's look at the next page. Translating a speed time graph into a distance time graph. Okay, similarly with what we have done from distance time graph to speed time graph, we'll work with portions. So here we're going to work with the first portion, which is this upward slope. So here is the working. So the distance in a speed time graph is the area under the graph. So first portion of the graph is a triangle, so we're going to find the area of a triangle, which here is half times base times height, which is half times 30, which is the height, and 20, which is the base. And then we'll find the area for the next part of the graph. If you look under the graph, it will be a square, as in, sorry, it's a rectangle. So a rectangle is base times height. So I have 600 meter. And then finally, this downward slope, which I found here, is 150 meter. So now we will translate that into the distance time graph. So if you have an increasing speed, it will show an increasing gradient in the distance time graph. So here I have a curve, a decreasing gradient curve, an increasing gradient curve because there's an increasing speed. And then for constant speed, you will have a straight slope. And lastly, for a decreasing speed, you will have a decreasing gradient. Okay, so the gradient is important when you are translating graphs. Okay, I will not show you the speed and speed time to acceleration time graph because it is similar to the speed time and distance time graph. But there are things that I want to highlight in the exercise. For example, in the first question here, the word retardation is a synonym for deceleration. Okay, and then another one, hold on, I'm looking. Yes, here. So the word uniformly, it is used similarly to the word constantly. Okay? Okay, so that's all for today. I hope that is beneficial and it will help you with the exercise. Alright, thank you.